Let's see, I got 2, 4, 5, 6. Should be 7. Okay, I think we're looking good. We're streaming, so I'm gonna go ahead and turn the audio down on the music card. Hopefully, it's having a hard time. We're gonna do the best we can with what we got going today. Okay. Let's put this back. And let's show this screen for the people at home. Yeah, it's moving really slow today. That's what I spent most of my day, is just trying to speed up the computer. But it's totally dragging today. But we're gonna do the best we can. Let me check one other thing. I think that stuff is okay. Looks like my audio is good. Okay, we're gonna go with it. So we had a little bit of a late start, just a little, but we're here, okay? I hope everyone is doing well. I think exam 2 was due last night, this morning at midnight. You can still submit it with the 10% late penalty. So even if you want an A on it, you can still get it. It would be like an A-, like if you were to get a perfect score. I'll get your midterms grade posted shortly. I'm probably just gonna abandon the auto grade thing because I just hadn't figured it out. So that's what I was working on. That's part of the reason why I was late. I was working on grades, but everything is moving slow over here for some reason. So I had to call AT&T. It's like, hey, I'm not paying for it to be slow like this. Like, so, but by the next time we meet, the midterm grade should be posted, and we can discuss anything that you all want to discuss. So what we're doing today is similar to the last couple of lectures. I'm just going to do the live stream for the lecture portion instead of doing it in advance. I just was not able to do it in advance. Okay, so I am monitoring the chat, and feel free to unmute yourself as usual if you have questions. Otherwise, we're just going to kind of hop into it and get the party started. Again, I hope everyone is doing well. I hope you're having nice weather. We're having really, really nice weather here in Atlanta. Hopefully you can take advantage of it. Get what you need done. Get it done. But take advantage of the weather as well if you can. Okay, guys. And again, if you have questions, feel free to either unmute yourself or type in the chat. I monitor both of those. They both Ali Oxenfree. They both seem like they're working okay. So we're just going to go with it for now. Okay. All right. If you have questions or anything. So with that, with exam 2 being available last Wednesday and it was due this Sunday, that should have been over chapter 3. So we're moving into the final chapter for the semester, which is going to be chapter 4 in integration. So where we spend a good amount of time talking about differentiation, which is going to give us the slope of the tangent line at a point. So suppose we're giving a derivative, we're given something and we're saying, hey, this is a derivative of another function. Integration is basically working backwards. So given a derivative, how can you figure out what the original function was based on the derivative, right? So we're going to explore some techniques and concepts behind working backwards, the reverse of differentiation, okay? So let's see how it goes. Keep in mind, I don't look at these things in advance. I probably should, but I don't. I just do it on the fly. So sometimes it does get me in trouble, but it should be okay. So let's see. So we're going to open up with this notion of what do we mean by anti-differentiation, right? So when you see the prefix anti, that should be a primer, right? So some objectives here, we want to find an antiderivative of a function. We would like to evaluate indefinite integrals using basic rules of anti-differentiation. We want to use initial conditions to determine an antiderivative, okay? So we have this first theorem. It says that the antiderivative of f is the set of functions, capital F of x. Give me just a moment. I think he was here. I think he got his attendance credit already, but let me just check and make sure. Come on. Awesome sauce. Let me see. Oh, no, he was not here. Yes, let me give them credit. Cool beans, and let me let them in. Admit. Cool beans. Okay. So, again, if you're just joining us, somebody had a question? You guys okay? All right. So, if you're just joining us, we're moving into chapter 4, and this notion, or this, we're exploring this idea of integration or anti-differentiation. So where we've been looking at the derivative for these past couple of chapters, now we're going to see, okay, given a derivative, can we work backwards and find the original function, right? So that's what anti-differentiation is, or integration is, right? Okay, okay. I keep getting nervous about my audio, but I think it's fine. So the antiderivative of f of x is a set of functions f of x plus c, such that when you take the derivative of that result, you finish with where you started, right? So in other words, we're basically working backwards. We're given a derivative, can we find the original function? The constant c is called the constant of integration. And we'll talk more about that constant of integration, but basically, you know, whenever you do the antiderivative or take the integral, for right now, you need to include just a generic constant. So c just stands for a constant. And you'll see why momentarily why we do that, okay? So then now we have integrals and integration. So anti-differentiating is often called integration. To indicate the antiderivative of x squared is x cubed over 3 plus c, we write the integral of x squared dx is going to be x cubed over 3 plus c, where the notation this is used to represent the antiderivative of f of x, right? So I usually read this, the integral of f of x dx, okay? More generally, the integral of f of x dx is going to be the antiderivative of f of x plus some constant, where f of x plus c is the general form of an antiderivative of the function. Okay, so that's just like a little bit of backstory. Let's kind of see it in action some. So in this example, we're asked to determine these indefinite integrals. That is, find the antiderivative of each integrand. Okay, so if we want to integrate 8 dx, you kind of like, you think to yourself, okay, well, the derivative of what function is 8? Well, then that's going to be, the antiderivative here is going to be what, 8x plus some constant, right? And the way we check, if we took the derivative of this, if we took the derivative of what you see, the derivative of 8x is 8. The derivative of a constant, this will go to 0, right? So the derivative of this entire thing is going to be 8 dx. Let's do another one. Okay, so now we have the integral of 3x squared. So what we want to do, we're going to add 1 to the exponent and divide by that new exponent, right? So then what this is going to be the same as 3 times x cubed, and let me write it like this. We did the 2 and we said plus 1 divided by 2 plus 1. Plus a constant, okay? Let's sit on it. Who do we have? Let me get the student credit. Give me just a moment. So we're going to simplify that, and we're going to check our antiderivative with by taking the derivative. Let's see. We have. Yep, there's that student. Cool beans. You're still looking good. I'm going to let them in. Okay, and so if we simplify this, we have what? It's going to be x cubed over 3, and the 3's cancel, so then we're going to have x cubed plus c, right? So our claim is that the integral, or the antiderivative of 3x squared, is going to be x cubed plus some constant. And again, we can check, if we take the derivative of our result of this guy, the derivative of that is going to be 3x squared, which is what we wanted. And remember, the derivative of a constant, that will go to 0, right? So we would check by taking the derivative, okay? So if we have e to the x dx, let me see, I think that's going to be, should just be e to the x plus c, right? And just, you check by taking the derivative. What's the derivative of e dx? Is itself, so that's okay. And again, the derivative of c is 0. The derivative of a constant is 0, right? We're going to let that be for now. The derivative of what function there? Because like I think if we were to write this as x to the power of -1, and if we add 1 to the exponent, we're going to get to 0. And x to the 0, the derivative of x to the 0 is not this guy. So the function that has this derivative is going to be log x plus some constant, right? I think we mentioned that the derivative of natural log of x is going to be 1 over x, and then it's the same argument every time we have that constant. The derivative of a constant is 0. Okay, hopefully that makes sense. It should make sense. So again, the concept here is we're given a derivative, we want to work backwards and see can we find the original function, right? So I'm just going to kind of keep working examples, and hopefully some of these techniques will sink in. Now, I think we have a typed version of what we just did. I think we got the same results. And then again, notice in red it says check. Make sure that when you take the derivative, you get the f of x that you started with. Okay, let's keep going. Let's do another one. So then we have theorem 2, basic integration formulas. So the first one says the integral of a constant, is going to be that constant times x plus another constant. So again, k is just some constant. So like if we had the integral of 2, the integral of 2 would just be 2x plus a constant. Like if we look at our previous one, we had the integral of 8. We finished with 8x plus a constant. Okay? So the integral of a constant is going to be that constant times x plus a different constant. The integral of a power is going to be x to the power plus 1 over that power plus 1 plus additional constant, right? This is like the second one that we did. We said x cubed over 3 and the 3's cancel. We finished with this guy. Okay? So we just added 1 to the exponent divided by that new number, and right now we're always adding on a constant because when we take the derivative, the constant goes away. So that's, so there's like infinite number of results that when you take the derivative will give the result that we started with. To integrate a power other than -1, increase the power by 1 and divide by the increased power. All right. Keep going. So now if we're integrating 1 over x dx or dx over x, that one is going to be the natural log of x plus c. Okay, if x is negative, then it would have to be the natural log of absolute value of x. Because again, natural log is not defined for negative values of x. Like that part inside has to be positive, strictly greater than 0. We generally assume that x is positive for our examples. Then if we have some constant times an exponential raised to the power of ax, so then the integral there is still as itself. The e holds, I think the b holds, and we divide by the a there. Right? That takes a little bit of effort. Just whenever you get your result, you always check by taking the derivative to make sure it works out. If it's not working out, then something's not right, right? So we'll work a few examples to test it. So we're actually use the power rule of antidifferentiation to determine these indefinite integrals, okay? So we're working on part A, 2A. I'm going to start here. We have the integral of x to the power of 7 dx. So what we're going to do, we're going to add 1 to the exponent and divide by that new exponent. So this should be x to the power of 8 over 8 plus some constant. And again, if we check by taking the derivative, the 8 comes down, the exponent becomes 7, and the derivative of the constant goes to 0. So I'm going to go with that. So then for 2b, we're looking at the integral. We got x to the 99 dx. Same thing, right? Add 1, it should be x to the power of 100 over 100 plus some constant. And again, if we take the derivative, we should get the original. 2c, we want to find the integral of the square root of x dx, okay? Let's see. So we can rewrite this as a power. The square root of x is the same as x to the power of a half. So if we apply the same technique, now it's going to become x to the power of 3 halves over 3 halves plus some constant. And then you can flip and multiply. I'm going to leave it at that, but you can flip. It'll be 2 times the square root of x cubed over 3, all right? So I'm going to leave that for now. We're going to go ahead and do part D. We're looking at the integral of, we have 1 over x cubed dx, okay? This is the same as x to the -3. The main one that we have to be on the lookout for is if we have x to the -1. That's not this case. So we should be able to do the same thing of adding 1 to the exponent. So then this is going to be, if it's -3, if we add 1, it's going to be x to the -2 over -2 plus some constant, okay? And then if we take it a step further, it should be 2x squared under 1. It should be negative plus some constant. Since we took a step further there, let's go ahead and do this one too. This is going to be, you can say 2 times the square root of, I don't like the way that looks though. 2 times the square root of x, this quantity cubed, and it might be written in a slightly different way, but it'll still hold, over 3. Okay, let's check these results. So we got, let's see. I think you see what we got right here for that one. You see that one there. And again, notice they're checking by taking the derivative. They're checking by taking the derivative. You see, okay, so they did leave it like this. So we didn't have to go further than where we had it originally. 2/3 x to the 3/2 plus c. I think we got that. Okay. And then the last one, I think we got this result as well. Negative 1/2x squared plus c. Okay, let me just check the chat really quickly. I think the chat is okay. Okay. All right. Let me see the time. As we started at 6. Okay, we're doing pretty good on time. Okay. Oh, and this is a quick check. If I remember, especially if we have time at the end, we'll come back and get this to go. Otherwise, I'm going to I usually leave that as an exercise. In this example, we're asked to determine the indefinite integral. Okay, let's give it a go. So we have the integral of e to the 4x dx, right? Now, you might be tempted to just do e to the 4x plus some constant. But if you take the derivative there, the derivative is going to have an extra 4 on the outside, right? Because the derivative here is going to be itself times 4. But notice that times 4 is not here. So we need to introduce another term, so we need to divide by 4. Now when we take the derivative and when we bring down the derivative of the exponent, the 4's cancel and we finish with this result. Okay. Again, the main thing is just to keep checking by taking the derivative. Okay, and here's a type version of what we just went through. So we know that the derivative of e is itself, right? So it is reasonable to make the initial guess to be e to the 4x plus c. But again, this is slightly wrong because when you take this to the derivative, notice there's the extra 4 that we were talking about. So to adjust, we modify our guess by introducing this 1/4. And I think that's exactly what we got right there. Because now when we take the derivative, we finish with the desired result that we anticipated. That we started with. Okay. We'll come back to the quick check. Let's look at this theorem. Time permitting on the quick check. Properties of antidifferentiation. So property 1, the integral of a constant times the function dx is going to be the constant times the integral. So basically it's like the constant can move to the outside of the integral and it'll preserve the equality. The integration of a constant times the function is the constant times the integral. Okay, that's the long and short. The integral of a sum or difference is the sum or difference of the integrals. Again, the integral of a sum or difference is the sum or difference of the integrals. Okay, so it's kind of like you can distribute the symbol into the sum or difference, right? It's just like how we were taking the derivative. Okay, determine these indefinite integrals. Assume that x is positive, okay? So if we're working part A, this is 4a. I'm going to just kind of go ahead and distribute. Well, I'm just going to kind of jump, right? So if we focus on this first term, this is going to become x to the 6 divided by 6. Let me write out. So we're going to have 3x to the 6 over 6 plus 7x cubed over 3 plus 8x plus some constant. Okay, we can go a little bit further. This is going to be x to the 6 over 2 plus 7x cubed over 3 plus 8x plus some constant. Okay. And then for B, so I'm going to rewrite that before I take the integral. Yeah, that's some funky stuff going on there. So this is going to be the same as the integral. We're going to have what? 4x to the -1. So you got to watch out for that. So we'll talk about that momentarily. I think this is okay. Plus, this is going to be what? 3 plus 2x cubed dx. Okay. So then when we apply the integral, remember the -1 it becomes natural log. So that's going to be 4 times the natural log of x for the first term. The second one is going to become 3x. The third one is going to become 2x to the 4/4 plus a constant. So it looks like we finished with, you could even rewrite that as the natural log of x to the 4, but I'm going to leave it as 4 ln x plus 3x plus x to the 4/2 plus some constant. Okay, let's copy. We're going to paste, and we're going to compare it to our prepared notes. Okay, let's see, how do we do? X to the 6/2, x to the 6/2, 7/3 x cubed. I think this one is good. Like, I think we got that exact same thing. This one, you see the 4 natural log of x, 3x, x to the 4/2 plus a constant. I think we got that result as well. Okay. We have another quick check. Let me see the time. 6:30. We might go back and do a quick check, 1 or 2 of them. It's like our time. We're doing pretty good on time. We might have like 1, maybe 2 more. Find a function f such that the derivative is x squared, and then find f of -1. Okay. So basically, it's asking us to find the integral of x squared dx. So then that's going to be x cubed over 3 plus some constant. Okay. They might. Oh, okay. It says, and then it gives us that f of -1 equals 2. So right now we're at f of x equals x cubed over 3 plus a constant, but then they give us an ordered pair. So when x is -1, that's going to be -1 cubed over 3 plus a constant equals 2. It just depends. I'll accept it. When is this? I don't really care. I'm just going to reserve it. I might be up. Cool. I don't care. Okay. Oh. So then now we can solve for c. Let's see. We get a -1/3. So c is going to be 2 1/3. 2 plus 1/3. So then c, let me see. 7/3. So then our function that satisfies these conditions should be x cubed over 3 plus 7/3. Okay. So we can check this. Let's paste. We can check this. Let's see. So when x is -1, we're going to get -1/3 plus 7/3 is going to be 6/3, which is 2. That's what we wanted. And then if we take the derivative here, the 3 comes down, they're going to end up canceling, and we're going to finish with x squared. The derivative of a constant is 0, so this checks out. Let me check the chat really quickly. Chat looks okay. Okay. Let's keep moving. Let me check the stream as well. So yeah, I just wasn't able to like make these in advance. So it's like if I don't do it in advance, then I try to go out of my way to just do it live during class time. I try to do it in advance, but sometimes I just get busy and I just don't get it done. But it's okay. Okay. So we got x cubed over 3 plus 7/3. Okay. So notice when they integrated, they had the plus c constant. And then they plugged in the given ordered pair. So when x was -1, y was 2, and we got that value for c, so then this is our f of x. Okay. There might be one more. No, that was it, yeah? Okay, let me see the time. We still got, let's go back and do a few of the quick checks. Let's give those a go, right? Because we essentially did what we wanted to talk about today. Let me go back and try a couple of those quick checks. We're gonna work backwards, and I'm gonna just watch the clock. I won't keep you past about 7 o'clock. Quick check. Okay, I know the results are there. What I'm gonna do, I'm gonna get a copy of this and see, make sure that we can arrive to those same conclusions. I got quick check 3. Let's copy. Let's paste. Let's paste. We got 3 of them. I just want to move this out of the way for right now. And I'll go like this. I want to go to crop, and I want to get rid of, I know we have the answer, I'm just kind of ignoring it for right now. Let's do like this. Okay. And if I go crop, okay. And I just put that on another page, on the next page. Let me add a page. I can just like delete that, delete, and I'll paste it here. Okay, I'll come back to that. I'll use that later. And we want to work on this. Okay, let's go view, seamless, paper, and let's add some lines. Okay. All right, so let's give this one a go. Let me see the time. Okay. So yeah, this one isn't too bad, right? Keep in mind we're essentially like distributing the symbol. Like it's similar to when we differentiate. We're not really distributing, but that's, you can think of it that way and you'll be fine. But if we do the antiderivative on each of these terms, the first one becomes, so this is going to be equal to 2x to the 5th over 5 plus 3x to the 4 over 4 plus, nope, minus 7x to the 3 over 3 plus x squared over 2 minus 5x plus some constant. It doesn't look like anything simplifies, so I'm actually just going to go with that. Let's work on part B. I want to crop. Okay, let me check something. That's good. Okay. So now let's give this one a go. Let's see. I don't know about a chain rule, but we could expand it. Yeah, I think I'm gonna just this one is simple enough to expand. Let me see. Okay. So yeah, let's expand this and just do it that way for now. This is going to be equal to the integral. That's going to be x squared minus 10x plus 25 dx. So then now it's just what we've been doing, and it's going to become x cubed over 3 minus 10x squared over 2 plus 25x plus some constant. And then we can take it one step further. X cubed over 3 minus 5x squared plus 25x plus some constant. Let's give me just a moment. So we got x cubed over 3 minus 5x squared plus 25x plus some constant. I didn't like how jammed I had my original. So I just wrote it like normal, then I'm going to move it to where it needs to be. Move it and resize it. Okay, I'm going to go with that. And then I'm going to go ahead and load part C. I want to paste, expand, and I want to crop. And again, we already have the results, so it'll be easy to check. Aside from taking the derivative, I want to crop. Actually, we have the results here for A and B. So A, 2x to the 5th plus 3 over 4x to the 4 minus 7/3 x cubed plus 1/2 x squared minus 5. Okay, that's good. And then for part B, 1/3 x cubed minus 5x squared, 25. Okay, so that's fine. Let's just go ahead and do the third one. I'm going to go ahead and crop out the result, and I'm going to crop down to here. And I just kind of want it to be similar size as the others. Okay. Let's see. Let's do a similar thing that we did in the previous one. This is going to be the same as the integral. The first term is going to be a 1 minus, we're going to leave that as 7 over x, because that's the natural log one, plus 2x to the minus 2. And we want to say dx of all of that with regards to x, okay? So then when we take the integral, the first one is just going to be x. That's going to be minus 7 natural log of x. So that's going to be minus 2x to the minus 1 plus some constant. So negative 1 comes down, that becomes a negative 2. Okay, I think we're good. Okay. That wasn't too terribly bad. Let me pull, I'm just going to use this right here really quickly to just compare. So this is what was already there for the quick check. We had x minus 7. Sorry, x minus 7 natural log of x minus 2 over x plus a constant. Yeah, that's correct. Delete. Okay. I'm going to delete that page. And let's do our view. Back to single. Let's see the time. All right, let's see what else we got. So, yeah, and I think we got that already, right? Okay. So we did quick check 3. I'm probably going to go ahead and make quick check 2 the last thing that we do today. Find each antiderivative. I would have to, would be better if I could prep those in advance. I know what else I can do that's a little bit faster. What page is this? 18. Let me copy and paste. And then what I'm going to do is just basically blot out the answers. And hopefully that didn't cause too much trouble. Crop. Oh, see, there we go. Oh, where'd it go? It's being totally temperamental. Example 3 concluded. Quick check 2. Is that it? Okay. I just want to crop this. Copy. Paste. I'm going to just shrink this down a little bit, and you can actually go right there. I think we're good. Okay. So and I think we got the results on the next page. Okay, so let's get this one to go. So, you know, it's just a good place to start with the E is just going to be the antiderivative itself. But if we take the derivative, we're going to have an extra -3 on the outside. So again, we need to divide by -3 plus some constant. And then for the second one, it's similar, right? It's still going to be itself, e to the 1/2 x. But then I think we need to still divide by the 1/2. Or another, divided by 1/2 is the same as multiplying by 2 plus some constant. That wasn't too bad. I think I'm spent. Let me see the time. Man, we get through these fast. Let's see. So e to the -3x over -3, e to the -3x over -3, and then 2e to the 1/2 x. Okay. I know I said this was going to be the last one. I might as well just go ahead and do the first one. We got a good amount of time. I spent more time just setting it up properly, like setting up the page, than actually working it. Okay, I think I'm spent. So if you guys don't have any like burning questions, I think I might let you guys go. Let me see. The chat looks okay. I mean, what we did was enough. That was more than enough. Let me see as far as any announcements. So again, like exam 2 is available. It was due this last night at midnight. But you can actually submit it late and still get 90% credit, like with a perfect score. So it's only a 10% late penalty. We're entering the home stretch. Chapter 4 is going to be the last of the new material that we talk about for the semester. I think we're going to do all sections in Chapter 4 except for the very last section in Chapter 4. I want to say we're approaching the final exam. That'll be like that first week of May. So we'll see where everything falls. And we're going to have to be in high communication for scheduling for the final. And I'll get your midterm grades posted shortly. I was working on that early today. It's just my internet was moving like really slow. So, okay, if there aren't any burning questions, we're actually going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.